Hello, I'm excited to be talking to you about DevOps resiliency today at Ignite. My name is Gopinath. I worked on many DevOps products, including Azure DevOps, Azure Pipelines, and currently I'm working on GitHub Actions for Azure. You can follow me on Twitter at GOPINACH. In the current environment where employees are working remotely, for enterprises, the resilience DevOps practices have become very important in achieving code to cloud automation. Let's learn some of the challenges that are there, what practices that they can use in the enterprises. So our agenda looks like the first one. I will highlight some of the DevOps challenges and one reference architecture. I'll show you lots of demos on how you can achieve some of these challenges. The first challenge in the DevOps is compared to 10 years ago, releases have become faster. The releases have become 7x faster if we just compare to 10 years ago. And people are using DevOps practices. They have achieved this through code to cloud automation. But the most important thing is how reliable your pipeline is, how consistent your pipeline is, how much level of automation you have done is the one that is very critical for you to innovate faster. The second challenge is security. In fact, many enterprises do not realize the importance of security until they face an incident. What we learned is 62% of the enterprises do not integrate security in the development phase. So shift left is a powerful mechanism that will help you overcome some of the security challenges. The compliance is the next challenge. It takes months for enterprises to realize if their product is fully compliant with the practices or processes that are defined. And for some of the industries like health industry, compliance is very important. Now, how consistently you are applying this compliance at all stages is an important challenge. Governance. And based on the survey, what we learned, 86% believe remote work is the future. Now, if remote work is the future, how do you make sure there is an audit that happens? How do you make sure there is traceability that is happening across all the products that you are using? And how do you make sure that the consistent process, consistent tools are used across all the software development practices becomes an important challenge as well. Now let's see how we can overcome some of these challenges. Here is one reference architecture which shows the development lifecycle with steps. The first one is the dev inner loop. Now developers would like to use their favorite code editors or IDEs, but what is more important is there a dedicated dev cluster that is available to them to continuously code, test, debug so that this inner loop is very fast. The second one is about whatever code that is getting developed. Are we storing that in a version control? And from that version control, can it pick up and then have a build and release pipeline which can automatically build your code, which can automatically test your code, which can automatically deploy your code? This DevOps pipeline is the code to cloud automation that is very, very important. Now, number 4 practices everything as code. Can you store your pipeline as code? Can you store your infrastructure if you're targeting like Azure ARM templates as code? Can you store your policies as code? When you store it as code, you can achieve the reliability again. You can achieve the collaboration among team members, and you can consistently use a pipeline to deploy it. The number 5 is really about combining the number 3, the pipeline, and everything that you have stored, the infrastructure or application as code, and deploy automatically to your dev environment, staging environment, and a production environment. And number 6 is about policies. How can you define these policies? How can you store these policies as code and apply the same policies across all development environment, staging environment, production environment so that it is consistent as well? And number 7, once your code is in production, have you enabled monitoring and logging? And are you monitoring the health metrics? Are you monitoring the usage metrics? And using these health metrics and usage metrics, you can really validate your hypothesis and then see if your product or a feature that the developers have built is performing well in the market. If not, that's a learning and you want to take it through the feedback loop. Or you will go talk to the customers and then you will learn from them what features are working for them, what new requirements that they have, and then you will go back to the inner loop. These are the 8 different steps that happen in it. Now, if you are targeting Azure, like in this example, you're targeting a Kubernetes cluster for your application, what tools that you can use? We have given this reference architecture with GitHub as your source control system, with GitHub Actions as your DevOps pipeline, with Azure ARM templates as your infrastructure, and Azure Policy as code. So in the next set of demos, I will showcase you how you can achieve this reference architecture and how you can overcome some of the challenges that I just talked about before. All right, now we are into the first demo. And in the first demo, I'm just taking the same reference architecture and I will highlight 3 steps in it. The first one is the pipeline that we can create, end-to-end pipeline for building and testing your application and deploying to dev cluster, staging, and production. And the second one I want to highlight is everything as code. How can you store your pipeline as code in GitHub Actions? And how can you just store your infrastructure as code using GitHub, and also use the same pipeline? That's number 5, is using the same pipeline to provision the infrastructure and deploy your application. Let's jump to the demo. Here I have my code, a simple application which is targeting a Kubernetes cluster. The first thing I want to show you is all our templates are available here. The ARM templates are available here, where I am actually creating 2 key resources. One is the ACR, Azure Container Registry, and the Kubernetes cluster. So I will use this template to provision and then deploy it. And next thing I want to do is I want to take a very simple application where I want to build my Docker application and then deploy it to the dev cluster and staging and production. So is it easy, to create GitHub Actions? Let me just show you how easy to create GitHub Actions. I'm just starting with a new workflow. Now, when I started new workflow in GitHub Actions, it actually just gives me a built-in templates that I can actually just use. Like in this particular case, if mine is a Node.js application, I can deploy to Azure Web App, whereas I'm deploying to Kubernetes cluster, so I will just start off with my own workflow. So it gives me a simple workflow to get started, but I already know that I'm targeting Kubernetes cluster. Now, where do I go? If you go to github.com/Azure and Actions, you will actually find all the GitHub Actions and workflows that are needed for you to target any resource. So in this particular case, we are actually targeting a Kubernetes cluster. So you will actually find all the GitHub Actions for Kubernetes cluster and also sample YAML files that are needed for you to create. So I clicked on the KDS deploy. Deploy action is what you will use to deploy. Now, if I just scroll down, it just talks about, what's this action about, what its parameters are. In addition to that, it actually just shows me YAML snippets. So I already have an end-to-end flow that is available here. Let me just, paste this workflow, and this workflow will actually help me build my Kubernetes cluster and deploy it to the Kubernetes cluster. So all I need to do is just replace this entire thing so I can build my container image and then deploy it. So that's it. Now my pipeline is ready. This is the main.yaml pipeline that is created. What I have done is I have actually created a pipeline which not only deploys to dev, staging, and production. Let me walk you through that. So as I talked about, the ARM files are available here, and there are manifest location is where all the Kubernetes files are available. I'm now clicking on the workflows. This is where the pipeline is created as code. So in the first pipeline, like I have shown you, doesn't contain any of these variables because it was targeting to a single stage. Now here I am targeting to 3 different stages: dev cluster, staging cluster, and production cluster. And like if you just see, we are using a single resource, that is one container registry, and then the same image gets deployed to it. By the way, that's another important practice that developers must practice. You won't use the same image and then it should just go through the exact same pipeline. So you're deploying the image that is actually getting tested. Now, if I just scroll down in the build, we are building the image and then we are pushing our image to ACR container registry. Now, after that, I will show you the dev cluster. And here we are actually provisioning and deploying our application. This is the number 5 step where I'm using the exact ORM deploy dev JSON file to provision using a simple step that is first class now available. And the remaining 4 steps are about deploying your application to Kubernetes cluster. Now, the same set of 4 jobs are repeated for staging, like you can see, and then repeated for production too. Now, given that the YAML file is available in source code, like all the team members can collaborate, and then if you add a new step to it, the same step can be added across multiple stages. This is what will give you consistency. This is what will give you the faster 7x faster deployment, because we can automate all our deployments using this YAML file. Now, if I go to the Azure cluster and we went to the workloads, this is here is our app that is getting deployed. What I will now show you is we have something called a traceability that is available. And if I actually click on the get traceability, and once I authorize to the GitHub, it actually just shows me what exactly is the code coming from the GitHub repo all the way to the production cluster. Here is where the IT can now know what code is coming into them and what issues are getting fixed. Like if I just click on this, it takes me to the exact same code that I have actually just shown you. It's the same app, same code base. So essentially, you can navigate all the way from your production cluster to what changes that are getting deployed at any given point of time. Not only that, you can actually even go navigate to the issues that are filed and getting fixed. So phenomenal traceability is available between the Azure cluster and the GitHub code that is getting deployed end to end using just 2 simple clicks. So that's what is the first demo that we covered, where we have shown you an end-to-end pipeline. We have shown you a GitHub Actions simple pipeline, and also ORM infrastructure as code to target to dev, staging, and production. All right, let's go to the demo 2. Okay, now in the second demo, we are using the same reference architecture. We are now trying to take the policy, store the policy as code, and use the pipeline to automatically assign the policy to various environments. This is the automation that we want to achieve using Azure Policy and GitHub Actions. Let's jump to the demo. Now, if you go to the Azure Policy, you see a new menu item called Export Definitions. This will actually help you export your Azure policy to source code. So you can see I have a new repository, Azure Policy as code. And let me just go there. You can see that it is completely empty. Once I actually complete the operation, you should actually get the policy code available there. And next to the policies, and you can assign the policies at different scopes. You can assign at a subscription level or even at a resource group level too. What we want to do is we had a demo prod environment. That's where typically IT assigns the policies. Now we want to convert that policy assignment to the code. And let's export 3 policy definitions. One is allowed resource locations. You can deploy only to specific locations. These are the policies that the IT has already defined. Second one is the privileged containers. Do not allow running privileged containers in Kubernetes cluster. And the third one is the container image that you're allowed. So ensure only allowed container images can be deployed. So once these policies are taken into it, you can just export as a definition, or you can export a definition and assignment. What it will do is it will take the policies, store them into the code, and in addition to storing them into the code, it will actually create a GitHub action pipeline to automatically do the assignment. It will take a couple of minutes. While it takes time, let me just show you that we have already created. How does it look like? So in the same empty pipeline, so here are the three policies that are actually just assigned, and it contains the policy.json file and all the assignments that are needed too. Now if I go to the workflow file, you can see that there is, it typically creates one workflow file. This is the deploy policy to production environment, where it is taking all the three policies and assigning to production. What does it give it to us? Now anytime IT wants to do any change to the policy, now it is just going through the code. Given that it is going through the code, it helps you achieve full PR capability, because anytime you're updating it, you can submit a pull request, and others can review. It helps you in collaboration. It helps you in auditability too. Auditability perspective of who applied this policy, when this policy was applied, primarily through the code. Now, typically, one of the practices that IT we would recommend them to follow is always store your policy separate from your application code, and then clearly keep a different RBAC action. So in this particular case, we are just storing policies in this, and then create the appropriate workflows. Not just this, the deployment workflow I have shown. Other thing ID can do is they can actually create their own test environment, right? Take the exact same policy, create their own test environment. First, deploy to your test environment and make sure that the intended outcome is available in the test environment. Only if it is good, then you can promote it to production environment. Now, how does this help? This helps to today, if IT applies some of the policies in production, it can actually break the workloads that are running in production. Now, this automation, you are using the exact same policy, same automation mechanism to test it out first on the test environment and then push it to production. That's a significant improvement from the current story that IT follows. Not just that, if I actually go to the policy in Azure portal, if you have done the assignment, if I actually just open the definition, it actually shows full traceability of where this policy came from. You can just see this is the GitHub policy, and here is the repo that was used, and here is the run URL. Like from here, I can literally just click, control click, will actually just take me to the GitHub Actions pipeline run that that was executed to run this policy and assign this policy. That's phenomenal experience, where we are completely connecting and storing the code in the storing the policy in the code and automating it. Not only automating it, whenever you go to the Azure policy portal, you will actually just see which workflow file, which policy is getting assigned. Okay, now third demo. I'm just taking the same reference architecture, and then I really want to highlight on a couple of things. The shift left concept. Shift left concept to achieve two challenges. One, from the security perspective, how can you shift left and in the dev environment and in the dev cycles so that you can catch some of the issues a lot more faster? And similarly, some of the policy assignments, how can you shift left and achieve the policy automation and catch some of the issues earlier in the development cycle? Okay, now let me just shift to the demo. So I just went back to the same demo where we were deploying a Kubernetes application to production, and what we are trying to do now is, from security perspective, every code change, how can I just make sure that as part of the pull request of my code change, can I do a container scan and make sure that the changes that I am doing are not introducing any new vulnerabilities? That's the scenario I will show you. So I click on pull request. Now you can see here I actually just try to do a update to my code. Now as part of the code, one of the things is it is automatically running some of the container scan results. And if I just expand to the execution, you can see one of my code change actually is causing new vulnerabilities. Now, because of these new vulnerabilities, I can, my run fails. Now, as soon as my run fails, I can actually block from this change getting into even master. That's what is shift left of security that you want to achieve by completely blocking some of these as early as possible. Now, how do I achieve it? Like if I switch to the actions workflows that were created, we had previously, I've shown you CI workflow. Now there is a pull request workflow that is available where every pull request that gets submitted, you can run. And if your pull request is good, it will go through or it will fail. So how does the pull request code will look like? If I just click on this is the pr.yaml. So the difference between the first one and then this one is every pull request on branches to master, any time you are merging into master, you essentially run a container scan action. This container scan action will just go through, identify if there are any new vulnerabilities that are there, and then block your execution. So this is what helps you shift left and avoid any vulnerabilities getting into master branch and from there to production. That's one scenario I want to show as part of the shift left. Now, the second scenario I want to show you as part of the shift left is, I have shown you some of the policy definitions before, right? As part of the policy that are getting assigned to production, but we can, assign the same policies for dev and staging and production. Like every time your IT changes a policy, you can take the exact same policy and apply to even and dev and staging environments. Now, how does it help? Like, what scenarios it will solve? Today, most of the times, developers do their testing in their dev environment and staging environment. For example, one of the scenario is what resources you are allowed to create. Because of your compliance requirements, you are not allowed to probably create some of the production resources in different region. You can block it. Not just that, ensure only allowed container images or do not allow privileged containers that are getting executed can completely be blocked using the policies. And because they're applied at production, like when you run it, when you take your application from dev to production, sometimes you will see a surprises. Now, with the same policies, you can actually test it at the dev stage itself. So this is the policies that are assigned. Now, if I actually go to the Azure portal and then like assume, let me just open the resource location one. It's the same traceability that I talked about. But if I go to the assignments, you can see that the same policy is assigned to dev, staging, production, using the same workflow that was created. Now, when you run your application, this is the YAML application that I've just been deploying. Like if I just click on this, you can see that this code is violating the security. Given that it is violating the security, the error very clearly shows that denied by container, no privilege. Privileged container is not allowed. So you're able to test this out at the development stage itself. So developers can catch it much earlier than going to production. In that way, it improves the productivity and it improves the predictability of your application. So these are the three key demos that I was planning to showcase to you to overcome some of the challenges. So Today, I'm really happy to announce some of these new workflows that are available to all of you. First one is the Azure Policy integration that I talked about, which helps you to store policy as code in the GitHub repo. And also there are policy scan and assignment actions that are available. You can use them, for whichever stage that you want to. Next one, we have a ARM infrastructure as code deployment action that is available, where you can just store everything as code and then use our pipeline to do automation. And container scanning action, this actually helps you shift left and achieve the security issues or vulnerabilities to be caught much earlier. The last one is Azure image action for deploying to VMs too. What I have shown you is primarily container focused demo, but the exact same architecture that I have shown can be achieved even for VMs or even for web apps too. As the next steps, go to aka.ms/GitHub Actions for Azure Docs. Lots of material that is available, including some of the samples that I have shown you. I encourage everybody to go to this URL and then play with some of the samples and then provide us the feedback. Finally, today we are making you an enterprise DevOps report available at aka.ms/DevOps report. You can actually just go there, access this report. This report talks about some of the challenges, resilient DevOps challenges, and what solutions, what enterprises are using to solve some of these problems. Thank you for watching this session. I hope it was useful for you to learn some of the DevOps resiliency challenges and solutions. I expect you to try out GitHub Actions for Azure and then give us feedback. Thank you. Have a nice Ignite.